Hello, everyone. This is Feng Wang introducing our project Maximum Knowledge Orthogonality Reconstruction with Gradients in Federated Learning. And we start from introducing the background. Federated learning is a type of distributed learning that claims to preserve clients' data privacy by exchanging the gradient update of the model parameters and keeping the dataset local. But on the other hand, recent works such as deep leakage and gradient inversion find it possible to reconstruct the inputs from the uploaded gradients. However, there are some limitations in existing reconstruction attacks. They either only apply to small batch size, which may not be practically useful, or they suspiciously modify the network structure, such as adding an extraordinarily large dense layer, and can be detected by skeptical clients. On the contrary, our maximum knowledge orthogonality reconstruction, or MKOR in short, can recover the inputs with a large batch size because it is analytically optimized. Therefore, there is no loss function or iterative update in MKOR, and it has guaranteed reconstruction performance without any assumption on the dataset. Also, while we assume a malicious server, MKOR applies to unmodified neural network structure and avoid being suspicious. Then I will intuitively explain how MKOR works, and please see our paper for more details, or email me. The easy case of the network is that there are only fully connected layers. To reconstruct the input of the network from the gradients, we want to decouple several nodes in the second layer. That is to say, during the backpropagation, the weight in the first layer to each node is only involved on the samples from one class. Therefore, we may distinguish these gradients and reconstruct the input in each class, which is the gradient of the weights divided by the gradient of the bias. And of course, it's not the end of the story. For CNNs, such as VGG, the input of the dense layers is the output of the convolutional layers. So we want to reconstruct the input of the convolutional layers where we have the output and the gradients of the parameters. If we consider a very large batch size, then the gradient is highly averaged across different images and different locations in each image. Therefore, we can only rely on the output, while typically its size is much smaller than the input. So the best we can do is to get a blurred reconstruction. To maximize the information we get from the output, we modify a small number of parameters so that different output nodes tells different stories about the input, and we call it maximizing the knowledge orthogonality. Specifically, we set some of the convolutional kernels as in the diagram below, so that some will copy the input, some will take the opposite number, some move to the right, and some will move down. As a result, 75% of the output nodes are orthogonalized for us to reconstruct the input. To avoid being detected by the client, please see our paper for more details. Then let's see the theoretically optimized result in the experiments, especially when the batch size is large. This is CFAR100 dataset with VGG16 network, and we have 100 images in each batch. The upper left is the original input batch. The upper right is the reconstruction from MKOR, and the lower are the reconstruction by gradient inversion and class fishing, which focus on only one sample per batch. And we see our reconstruction is the closest to the original input. And this is the MNIST dataset with the Net5 network with 100 images per batch. Again, the upper left is the original input, the upper right is the MKOR reconstruction, and the rest are the reconstruction from other benchmarks, deep leakage from gradient, improved deep leakage from gradient, gradient inversion, and class fishing. Again, our reconstruction is clearer with lower error. And this is the VGG16 on ImageNet with 1,000 images per batch, and we randomly pick 100 to show. From left to right, they are original input, MKOR reconstruction with VGG16, and MKOR reconstruction with modified network. While all other experiments are based on the original network structure, we can actually achieve 100% reconstruction accuracy if we are allowed to modify the network structure. Even if we keep the original VGG16 network structure and such a large batch size shown in the middle, we can still read the content in our reconstruction. Thank you, and please let me know if you have any questions.